This is the video part 1 for August 23rd, August 24th, the day before our assessment. We mostly we try to review the reviews posted online already. These videos are long overdue, but we're going to go ahead and do a few of these problems. We already did this in the last video, so I'm going to scroll down. If you download these guided notes, which is attached to this blog post, and let's go over excuse me, these two angles here. So first here, we have this angle. We want to find all 6 trig functions of the following angle of measurement, theta. Well, what we've said is in class is if I'm going to draw this angle here. This is our point 12, -5. We always want to make a triangle with our x-axis. And since our x-axis is here, I'm going to go directly up to our x-axis. This is going to create our right triangle. And also in class, because we have reference angles similar to how we develop the entire unit circle, we have an angle theta, and theta is always going to be closest to the origin, so that's our angle theta. Now, what we can say is we have 12 and -5, so we want to use those points to figure out the sides of the triangle. Well, if I start here at the origin, if I'm like transposing this angle over here, if I start at the origin and I go this way, this point is telling me I'm going 12 to the right. So this side is going to be 12. That's what this x-coordinate tells us. We go 12 to the right. And maybe you're already saying, oh, okay, well that means it's -5. That's right. So if we go down 5, down this dotted line, directly down, that makes this -5. And hopefully we know that we can solve for this. This is our c. We can do that using the Pythagorean theorem, which I'm going to do over here. So we have our Pythagorean theorem says a squared plus b squared equals c squared. Let's call a -5. I'm going to put that in parentheses. I always put my numbers in parentheses because that helps me out. Now, this is a common mistake I'm seeing, is that we're saying that -5 squared is -25. But really -5 squared is -5 times -5. A negative times a negative makes it +25. 12 squared is 144. And this is equal to c squared. 25 plus 144 is 169. And then if we take the square root of both sides, we get c is equal to 13. Now another common mistake I'm seeing is that because our hypotenuse is going down, we might want to call this -13. But we might have negatives in future problems, but in this problem here, our hypotenuse, whenever we're solving for the hypotenuse, that will never be negative. So this is a +13. Now that we have that, we can find sine, cosine, and tangent. So let's say sine of theta equals cosine of theta equals tangent of theta equals. Well, we know that theta is here. Sine is opposite over hypotenuse if you use SOHCAHTOA. Sine is opposite, which is -5, over our hypotenuse, which is 13. So this would be -5 over 13. Cosine is adjacent over hypotenuse, so 12 over 13. And tangent opposite over adjacent, so tangent is that. Now it says all 6. We want to find secant, cosecant, and cotangent. Once we have these 3, those are quick and easy. Sine, we know that sine and cosecant are related. We take the reciprocal to find cosecant. So this is -13 over 5. Cosine and secant are related. So this is going to be 13 over 12. And cotangent of theta is -12 over 5. And those are our 6 trig functions. Okay. Now, I'm going to go through solving this triangle. I would recommend pausing it. Sorry, those are our 6 trig functions. Pausing it, trying this one on your own. If you want to get a head start or a little push in the back, if you will. This is our angle. This is -1, 1, our point. Always with the x-axis, so I'm going to go straight down, create our triangle, Negative 1 tells us to go left 1, so that's negative 1. Positive 1, go up 1. Now, if we were to solve for our hypotenuse using a squared plus b squared equals c squared, what we would end up with is c squared is equal to 2, and c is equal to square root of 2. Now, don't simplify that. Don't write that as a decimal. We want to keep that as a square root. Similar thing here. Also, sorry, you'll have negative 1 squared, but negative 1 squared is just positive 1. That's why it ends up being square root of 2. If you have questions about that, you can ask me. Oh, and theta is our angle closest to the origin. Now let's find sine, cosine, tangent. Sine, opposite over hypotenuse. This would be 1 over square root of 2. But we know, because we're smart mathematicians, we have to rationalize. Square root of 2 over 2. Cosine is going to be negative 1 over square root of 2. And if I did the same thing, it would end up with the same solution, but negative square root of 2 over 2. And tangent is opposite over adjacent, which is just negative 1. Now I can find sine cosecant of theta. Just a quick trick. We could go here, reciprocal, rationalize all of that. Or we could just go here. This is what we originally had. Let's say that, square root of 2 over 1. But square root of 2 over 1 is just square root of 2. Secant of theta, similar thing. We have square root of 2 over negative 1, which is just negative square root of 2. I'm just taking this one, not that one. We could do this, rationalize, you'd end up with the same thing. I would encourage you to try it, see if you end up with the same thing. Now this is another part. Tangent is negative 1. We need to take the reciprocal of tangent. Reciprocal of negative 1 is not positive 1. If we write this as a fraction, if it helps you, negative 1 over 1, which means the reciprocal would be 1 over negative 1, which is still negative 1. So we covered this in the last lesson, finding all 6 trig functions of an angle, any angle in the coordinate plane. Hopefully this is a good refresher. The next video we're going to look at conditions and how we can use conditions to find all 6 of any angle.